Hello, welcome to our Semiconductor education program. I'm Vincent Chang. In this lecture, I'm going to teach you one of the easiest yet important circuit theory in analyzing a microelectronic circuit, which is called source transformation. Let's start with an ideal voltage source. There is only one component, the voltage source Vs, in this model. But in reality, there will be an internal resistance associated with the voltage source Vs. So this form, Vs in series with Rs, is called Thevenin. Thevenin. The model on the right is the model for ideal current source. There is only one component, Is, in this current source model. So similarly, there will be an internal resistance associated with Is. So this form is called Norton. So Is in parallel with Rp. So again, on the left is Thevenin, Vs in series with Rs. On the right is called Norton, Is in parallel with Rp. So source transformation tells us we can make these two forms equivalent as long as we follow these two equations. The first equation, the series resistance on the left equals the parallel resistance on the right. The second equation, the current source Is equals the voltage source Vs on the left divided by Is. Why? So I wanted to pause for a moment to think about why and how to prove the equivalence of these two forms if we follow these two equations. Let's try to pause for 1 minute. All right, have you figured this out? Why? So now I'm going to prove this. Not just help you prove this, but get a better understanding, a deeper understanding about this, the equivalence of these two forms. Let me ask you, what's the two extreme? Means, what do you mean by equivalence? The equivalence means what? The equivalence of these two forms means in any condition, in any output condition, these two forms can be equivalent as long as we follow the two equations. So in any condition, let's give the two extreme conditions. The first one is when the output is what? Open circuit. In other words, when the load resistance is infinite. The second condition, when the output is short circuit. In other words, when the load resistance is zero. So infinity and zero. So case one, open circuited output. Open circuited output. When the output between X and Y is open circuit, then what's the green current? What is the green current on the left? Because it's open, then there's no current, right? So same thing on the right, because it's open, so there's no current. So the green current on both sides should be zero. So when the output is open, what's the open circuit output voltage? Based on the Kirchhoff Voltage Law, KVL, on the left it should be what? So because the current is zero, so there's no voltage drop across Rs. So it should be Vs. What about the output voltage on the right? So So the IS we're going through RP. So it should be what? It should be IS times RP. Should be IS times RP. So if the two form, the both output are open circuit. So then if they are equivalent, then in this condition, the open circuit output voltage should be the same. So we just put Vs equals Is Rp, give us the first condition. So case 1, open circuited output. What about case 2? I said short circuited output. Short circuited output. So the green analysis represent the first case. The second case, we use another color, blue color. So when the output is short circuit, so the short circuit output current equals Vs divided by Is on the left. What about the current on the right? Because the output is short circuit, so there's no voltage drop. No voltage drop across RP, so no current going through RP. So the IS will totally contribute to the output, right? So let's put these two, and why IS go to the output. So the red node is follow what? Kirchhoff Current Law, the KCL. So IS, are you with me? Equals 0 plus Is. So we can put these two output current, short circuit output current together. Vs over Is equals Is. So let's get these two cases, combine these two cases. The first one is open circuit output. The second one is short circuit output. Solve these two equations together simultaneously, give us this result. The first one, Is equals Rp. The second one, Is equals Vs divided by Is. Let's try to practice. Let me give you one example. Let's say if Thevenin is known, and Norton is unknown. Thevenin is known, Norton is unknown. So let's try to transform from the source from Thevenin to Norton. So on the left hand side, let's say the voltage Vs is 6 volt, Rs is 2 ohm. So I want to pause for 30 seconds and solve the current source Is and the parallel resistance on the right. Did you get it right? I believe most of you can get this right. So what about Is? What about Rp? Rp should be 2 ohm and Is should be 6 divided by 2 equals 3 ampere. If you can get this right, then you know how to use the theory, how to apply this theory, how to transform these two sources equivalently. Summary of the source transformation. So we are approaching to the end of this lecture, so let me remind you. The transformation is bilateral. It's bilateral. So you can either go from left to the right, from Thevenin to Norton, or from right to the left, from Norton to Thevenin. So let's say how to go from left to the right. Is equal what? Vs divided by Is. Rp equals Is. Let's say if Is and Rp are given, what about how to get the Is on the left? Just copy. just duplicate the resistance. And what about the voltage on the left? Vs should be equal to Is times Rp. If you get this, then you get this lecture. Thanks for watching.